Okay, hello everyone. So in this video I will show you how to use the Xilinx IC design shoot for doing the VHDL simulation or RTL simulation that we have discussed in the last class. Okay, so we'll see that. Okay, so I have the 14.7 this version, so I will open this IC design shoot 14.7. So I'll open this tool and then I'll show you the flow. Okay. So first you click on this new project and you should browse to a location. Okay, so you should mention the project location. So I have a CAD lab, so I've created a folder where I will write my project. So CAD lab is a folder. So I have to select this CAD lab, and then the project name should be there, right? So let's see. I will use the same example, the comparator that we have discussed in the last video. So comparator is there. So I've written the name of the project as comparator, and in the bottom there should be the top level source type should be HDL. By default it is like that, so no problem, I guess. So just press next, and then there is some project settings over here. So it is usually for the synthesis tool. Okay, so by default it is, for me it is Zinc, but since we are not going to do the synthesis, so first we are mostly interested about the simulation, behavioral simulation, so this doesn't matter much. So you can choose anything, any FPGA device you can choose, whatever it supports. It doesn't matter, these settings doesn't matter right now. So your simulator should be here is IC VHDL. So these are some default settings. Default settings is fine for you. Okay, so right now we can. Okay, so then just press next, and we should finish. So after that, just go over here in the left side. So this comparator project has been created on that location, CAD lab underscore comparator. Okay. So what I'm going to do is that I'm going to write a VHDL script. Okay. So I will just press over here, right click, and then new source. Okay. So new source, you just select VHDL module because we are going to write the VHDL module. So press over here in the left side, we select the VHDL module and then give the file name. So the file name is, our top level module is comparator, right, comparator. So just write comparator. So by default, since we have selected VHDL module, so by default it will be with the .vht extension. So then press next. Now here you can give the port name, port direction, and the bus, whether it is a bus or a single bit input output port. You can give this information over here if you write from scratch in this file. But I have already written these things into a separate file. Okay, so this code is written over here in a separate file. So I have already had that HDL code. So I will not mention it over because I will start from a blank script, and then I'll just copy this on that already written script. Okay. So just by default, whatever is there, I'll just select finish. Okay. So now you can see that in the left side it has been created. This file has been created, the comparator file, and by default it has given me a template. I'm not bothered about this template because I have written the code already, so I'll just make it clear. Okay, I just make it clear, and I will use my own code, whatever I have written for this comparator, right? So what you will do, we're just going to copy paste this thing. So I'm going to copy this and then I will go paste it over here. So now you can see, and then I will save it. So I've written this code in a generic manner. So you can check this is the code of my comparator.vhd file. Okay. Now okay, so just the last line is missing over here, so I have to write end behavioral, right? So I'm going to write things end behavioral. This was missing. So right, so this is my code for my top level entity with comparator.phd. Then I have to include my Testbench as well. So I'll just go over in the left side again and I will select my comparator, and then I will add a new source. Okay. Now this time I will choose the VHDL Testbench. So my source file type is it's going to be a VHDL Testbench code, right? So the name should be like comparator dot underscore TV. Fine. Now again you have to press next, and then I have to choose my top level module, means for which I have written that Testbench. So here only one top level module is there, so comparator is the module. So I will just by default I will select that, then I will press next, and then I will press finish. Right, now it will create the file. It will take some time, but you will be able to see the file in the now you have to go. So now there are two things. There is two view options in the left side. One is the implementation and another is the simulation. Okay, so now we are going to do the simulation using the Testbench, right? So just press the simulation. Now over here you can see that there is a comparator underscore TV file has been generated, right? So this is the file. By default the ISC tool has been created with a default Testbench template. So I don't bother about this template because I know how to write the Testbench. So I will just erase it, and I have already written a Testbench. I will just copy it and paste it. So, okay, so from my file, so I'm going to copy this thing and I'm going to paste it, and then I will save it. Okay, so now you can see that. So this is the Testbench of comparator underscore TB, where I have applied the stimulus using the sequential statements, using wait for statements, right? And this is the default, not default, it is the retained code for the Testbench code, right? So we have declared everything. Okay, so you know how to write the code right now, right? So obviously we can replace this part. You can replace this part by the concurrent statement, using the after statements, right? So you can do that, no problem. But here it is. I'm just showing the examples using the sequential statement and using wait statement, right? So I have to select this Testbench in the left side, in the left panel, in the hierarchy, and you must choose this as simulations. Okay, and then I have to select this one. Okay, select this comparator underscore TB, and then go to the left side, check the behavioral, check syntax. Okay, one thing you must also check that so you have to also check the syntax of my comparator.vhd. So I have not checked that yet. So first I will check the syntax of my comparator TB. comparator.bsd. So for that I will just don't need to synthesize it, right? So we are not bothered about synthesize, so I'm not interested to synthesize it right now. You can check that whether your code is synthesizable or not. You can check that if it is synthesizable, that is fine, because then that means that your code is, you have written the VHDL code using synthesize, all the syntax are synthesizable. Okay, so you can check that, and you can just, if tool says that your code is successfully synthesized, then it is fine. Okay, but you need to interpret that how to check the synthesis results, and since you are not familiar with what is the meaning of synthesis in case of FPGA, how to analyze the synthesis report, so we are not going to discuss that right now. So if you want, you can check the synthesis report. Okay, so tools suppose this, you can use that. But right now only we are bothered about the behavioral simulation, so that's why I will just use the check syntax. So otherwise it will take much more time. If I click the synthesize button, then it will generate all this. It will go through all these steps, and it will generate the post-synthesis simulations script also. So new files will be generated. So right now I will just want to check the syntax of my written VHDL code. So this clicking this thing is fine for me. Okay. So now I will check. I will wait for some time. My design will be compiled into the library, and it will check the syntax. And so it is just checking this comparator.vsd, this file. Okay, so now you can see that this has been completed successfully. Process 6 check syntax completed successfully. Now I go to the simulation again. Okay, I will go to the simulation again, and then I will select my comparator_tv, that is the Testbench file. Then I will check the behavioral check syntax in the iSim simulator in the bottom panel, that is the process. Now I check this one. So this is the script of my VHDL Testbench. So it is also successful, right? Then I will run on this simulate behavioral model, this option. Okay, now it will open a separate window with the iSim simulator settings. It will show me the waveform. Okay, this is it. So I will click on this simulate behavioral model. It will take some time. Okay, so now you can see that this separate window has been opened, and I can just use that. So you can see that my comparator has been this is the simulation result. What I can do is that okay, so you can check over here that it has been created the simulation results. So now we can, for every input you can check the output. Okay, so I can rerun these things, because by default the comparator total simulation time is 1 microsecond. So I can just rerun this, restart these things, and I can write my own timing. So it's already defined in my script, so that's why I think if I run it or run all, then my simulation will end at 600 nanoseconds. Okay. Now you can check that, because in the code that I have given 3 input combinations for A and B, right? and it ends at 600 nanosecond, and then I have used a wait statement that suspend the process indefinitely, right? So it will not be simulated, right? It will stop over here. So total 600 nanoseconds. So you can check this results over here, right? So now we can verify the results that during this time my G output is 1 at logic level high, and then during this time from 200 to 400 is what is the status of GEL, and then we can do the manual verification process, right? So we have only discussed the manual verification process, and that's it. Okay, so this is how we can simulate on ISC simulator, ISC simulator or ISIM simulator, and by using the VHDL Testbench code. Okay. So thank you for watching. Okay. If you have any questions, please ask me in the next class. Thank you.